Assalamualaikum warahmatullahi wabarakatuh. My name is Yasrina from class 1A. Today I want to share the method that I have chosen is the bisection method. Bisection method is one of the bracketing method, is an approximate method to find roots of the given equation. It is simple and always converge. So here I want to highlight this is our variables from the equation or our case study. This is our equation, and this is what our graph would be. Plot D versus FD. I will show it later. What is our outcome of the graph. And for the, I want to highlight here, this is our D upper, D lower, and D R. We get it from graphical method. Yep. And this is our if statement. We have set it. Our maximum iteration would be until 20. And for the first iteration here, the dr all will be the dr, and to calculate the new dr, we have to du plus dl divided by 2. And this is our if statement. Before that, I want to highlight this is our EA. That is approximate error, where we calculate absolute dr minus dr all divided by dr times 100. For the if statement here, as doctor can see, FDL times FDR. When it is lower than 0, the new du will be the old dr. Else if the FDL function by using d lower times function by using the dr more than 0, our dl our new dl will be the old dr. Alright, so this is our if statement. So our maximum here, I repeat it again, would be the maximum 20 iteration. And lastly, it will print the approximate error. We call it back what in our if statement here. And that's all. I will share the outcome later. For our bisection method, our iteration last would be at number 14. Here, why? Because we set our ES is 0.005, and at our 13th iteration it's still 0.007, which is bigger than 0.005, and at our 14th iteration it is 0.003. That's why it stopped here. We have here our D 0.116675, which is 5 significant figure, and our EA is 3 significant figures. So this is our findings.
Hello, my name is Afiq Azhar bin Muhammad Zaini. Today, I will present my method, which is first position method by using MATLAB. So, as you can see, this is will be set as the default before we start our program. So, from the equation, we will gather some value that will be inserted in this program, which is K1 equal to 40,000, K2 equal to 40, M equal to 95, G equal to 9.81, H equal to 0.43, and DS equal to 0.005. So, the function will be set into the program. This function we can get from the equations that we gathered. So, this is when we want to plot a graph, the range will be from 0.0 to 0.02. So we will set du equal to 0.2, dl equal to 0.1, and dr as default equal to 0. So this function we want to use as the header of the function that will show on the command window. So when we put the value, if fdl minus fdu is greater than 0, it will show error, or else it will show this header of the table. So for the start of the function, we will set I iteration from 1 equal to 20. So d old is equal to dr, du is equal to du minus fdu times dl minus du over fdl minus fdu. So this equation is the equation to find dr for the first position method. So this is the equation for the EA. This is the program that we set to show for the table. So the table will show I, D lower, dr, d upper, fdl times fdr, and ea. So this function is we will set if it show the fdl minus fdl times fdr is lower than 0, so du will equal to dr, while if fdl times fdr is greater than 0, dl equal to dr, or else fdl times fdr equal to 0, it will break. So this iteration is lower than 1, it will use the ea is equal to lower to ds. If not, it will break. So we will set as I iteration, the maximum is 20. So if we reach the maximum value, it will show on the command window, solution exceed maximum target. So for this, we use this program to set the graph. So we will plot df time over fd. We will set x as dm and y graph fd. So the title will be shown graph of fd versus d. So the grid will on and we set fy line equal to 0, the origin line. So if we will run, it will show the root when using the first position method is the number of the iteration and the final value of a. So we will run the program. So the graph is shown when we run the program. We can see the graph of fd versus d. We will see the intersection point at the y equal to 0 at here. So on our command window, we can see the table for the method. We will get the number of iteration is 6. We can see the 6 iteration. So the final root using the first position method is 0.166754 meter, and the final value of EA is equal to 0.00056,448%. We can see 0.0564. Thank you for me.
So this is the coding that I have come up with for second method. So from line 4 up until line 8 is the constant that were used to solve this problem. Line 9 is the size of the output that will come up for the value, while line 11 and 12 is the first and second initial approximate value, while line 13 is the pre-specified tolerance, while line 14 is the total value of the approximate percent relative error, while line 16 is the function that were used for this problem. Line 18 up until line 22 is the coding to plot the graph, while line 24 up until line 31 is for the output that will come up at the command window, while line 33 up until line 63 is for the loop that is to calculate for the iteration. So from this we can see that the loop will start with I equal to 0, and the loop will stop when EA is bigger than ES. Line 36 shows that the second formula to compute the new root, and from this coding, the formula to compute the approximate percent relative error is at line 55, and line 61 is for the output of the computation from the formula at line 36, and for line 64 at line 62 is to make sure that the iteration will increasing, and for line 64 up until line 68 is for the output of the coding. So next I will run the coding.
and this is the output that I get.
Hi, Assalamualaikum warahmatullahi wabarakatuh. This is my coding for Numerical. Okay, firstly, I state the parameter have been given in the problem statement, which is K1 equal to 40,000, K2 equal to 40, mass equal to 95, gravity is equal G equal to 9.81, KH equal to 0.43. Okay, the below is the equation function, equation definition. So the below it is first order derivative of f. Okay, we state the pre-specified tolerance is 0.005, and my initial guess is D1 equal to 0.1. Okay, this is my Numerical method. I choose the Numerical method. So this is the coding I choose to write. Okay, with the f solution was not obtained if the iteration I equal to 20. Okay, the lastly is f with the approximate root d equal to percent 0.5f and EA equal to percent 0.5f at iteration. Okay, so I will run this coding. Okay, after I run the coding, this is the output. So the output shows for iteration D1 SOL, which is xi plus 1, fd, and derivative order fp d1, and the EA. Okay, so the last approximate root I got is d equal to 0.16672, and the EA equal to 0 at the iteration of 5. So this is the workspace I got for every parameter I have. Okay, that's for me. Thank you.
Okay, Assalamualaikum. My name is Muhammad Amir Shafiq Hussein, and I'm from Group 5. And for this assignment, I have choose modified secant method as my numerical methods. Okay, firstly, we list the parameters data from the questions, which is K1 and K2, the spring constant, M, mass, G, gravity, H, height, and for the D, we set up the upper and lower value, and for the lower, we choose a 0.1 and upper 0.2. And then we list the equations from the questions and D as our unknown variable. And then we plot the DFD graph, and then we set up our initials, xi, which is 0.17, which is in range between 0.1 and 0.2 for our initial guess. And then xr equals to 0, xn 0, delta 0.01, Imax 10, and ES 0.005, and Fi equals to our Fxi. And if Fi less than 0, it will display error wrong endpoints, else it will display iterations, xi, xi plus delta si, fxi, fxi plus delta si, and ea. And I equals to 1 I max, xr all equals to xr, fi equals to fxi, and xn equals to xi plus times delta plus si. Fn equals to fsn, and then this is the modified secant method formula, which is xr equals to si minus delta times xi times fi over fn minus fi. And then fi equals to fsr, our ea formula, which is absolute sr new minus sr old over sr new times 100. Si equals to sr, and it will display the I, xi, sn, fi, fn, and ea. And if fr equals to 0, it will print the exact solutions was found. And when ea is lesser than es, it will break, stop the iteration, and then if I equals to I max, the solution was not obtained. And for the output, it will display the approximate root, number of iterations, and ea. Okay, now I will run this coding. Okay, and here is the graph result. Okay, and then here is the display of iteration xi, si plus delta si, fxi, fsi plus delta si, and ea. Okay, here we got 3 iterations of the rate of the convergence, and 3 iteration is the fastest method among all other methods. Okay, and then we get the approximate root value, which is 0.166755, number of iteration, which is 3, and our EA, which is 0.00193. Okay, as you can see here, after EA is the relative error is under 0.005, it will stop, and the rate of convergence of this method is just 3 iterations. Okay, that's all from me. Thank you.